So today we discuss the refraction of light through prism part B. Okay. So continuation of previous class, a topic of refraction of light. So part B, refraction of a light, refraction of a light through prism. Prism. So first question arises, what is prism? Okay, prism is a transparent medium bounded by the 5 plane surface with a triangular cross section. First, very easy test. First, triangular cross section here. Okay, and behind this another triangular cross section. We draw a dotted line. Okay, that is a behind and triangular cross section. So that is another triangular angle. Okay, that is behind. Now joining the line, joining a vertex actually, and we get a prism. Okay, so these two triangular cross section they are parallel. Okay, and the triangular cross section are parallel because this line and this line also parallel. This line and that line also parallel. So this and this also parallel, and that line and that line also parallel. Okay. So here it says that is a 4 vertex. So, sorry, that is not 4, 6 vertex. 1, 2, 3, 4, 5, 6. Okay, and there are the mainly faces. Here's a face. Here, this one face. Okay, actually, and the same of that side. Okay, phase 2, phase 3, front phase 4, down phase 5. Okay, and here the prism that suppose name A, B, C, D, that point is E and F. So surface ADEB, ADEB, okay, ADEB, and opposite of that ADEB, ADFC surface. These two surfaces are called reflecting surface. These two surfaces called reflecting surface. Reflecting surface. Okay, and these are called reflecting edges. These are okay. These are the called reflecting edge. These are reflecting thing edge. Now, so first we discuss the refraction of a light through a glass prism. Okay, so the diagram first. Suppose that is a front face. It's not okay. That is a front face. Okay, suppose ABC face here. Okay, actually that is a ABC face. Okay, now discuss refraction. Sorry, actually discuss a refraction heading refraction of light through through a glass prism. Okay. So here the two reflecting line here, actually see that all that is not, here is a front view, actually this is a front view, but actually AB, if I see from here, that is AB not a line, actually AB is a plane, and similarly the AC is looking that actually front view, that is the AC is a line, but from that here, if I some person standing here, then the person see that their AC is not a line, the AC is a surface. Okay, they are a plane. So if that is source, suppose source, and this line is called incident ray. Actually, if I do this, actually, is a source, that is ray is called incident ray, and AB line is called line of incidence. Okay, there's a line of incidence, and then we draw a normal on AB. So actually normal on AB, so that's the normal on AB. Okay, the yellow color line represents normal on AB. So that is called I1 incidence angle. So that is a source. Okay, that is a yellow color line normal. After striking the black color light, there is a reflection here, and that is a refraction. Now the refracted ray, because there is a two medium, suppose that is a medium 1 and medium 2, if medium 2 is more denser than medium 1, so actually ray of light is bent towards normal. Okay, so light travels from rarer medium to denser medium, so bend towards normal. Okay, but that is the actual path of light is go in straight line. Actually, when they are two medium are same, density are the same. Okay, line straight line actually. Okay, that is a straight line. Now, hmm, uh, that is a refracted ray. Okay, so if AC a line of incidence, so that a line is called a incidence ray. If AC is a line of incidence, so ray of light now travel denser to rarer medium. Now again you draw a normal, that is a normal. Actually, it's not look like normal. That is a normal. Ray of light is called normal. Okay, consider that is a normal. Okay. Normal, uh, then so light travel away from normal, because light travels from denser medium to rarer medium, so that's why the bends, so now bends, okay, the bending, that is a bending. Okay, now we check if that emergent ray, if that is a incident ray, that is a refracted ray, and that is the emergent ray. If I say that there is a glass prism, okay, there is the emergent ray. We discussed what is the emergent in previous topic, in the previous class. So if emergent ray also follow a straight path, if so, so there is a midpoint. Okay, so actually the source, if glass we have not placed here, so ray of light travel in that direction. Okay, but if that triangle glass prism, that's why that bending. Okay, actually path is deviated, huge deviation here. So that angle actually is called delta. It's called deviated angle. This angle is called delta. It's called deviated angle. Delta is deviated angle. Okay, so if I consider that is a name is I2 and that is name of suppose that is R1 and that is a R2. Okay, now try to calculate the delta. Okay, that is simply geometry. Okay, suppose we see that if I and angle I and delta. Okay, so name angle I1. Okay, okay, right. Now name that all vertices first. B, that is D point, that is a E point. Okay, and that is X and that is Y point. Now check the triangle DXY. DXY triangle, the delta is the delta, okay, exterior angle. So delta is the exterior angle and delta that is equal to, we know that exterior angle equal to sum of opposite of two interior angle. So delta equal to this angle plus that angle, and this angle is named, that angle is DXY. Okay, suppose call dxy, plus uh, dy dyx, dyx. Okay, and now you see that if this incident ray and that normal, okay, so that's why they cut, so that angle and that angle are also vertically opposite angle. Okay, that's two angle is a vertically opposite angle. So I1 angle that is vertically opposite of angle dxy, dxy plus r1 plus r1. Similarly, that normal here, that's yellow color line, and that emergent ray, they also vertically opposite. Okay, so that angle also equal to I2. So here I2 that is also equal to dyx plus R2. If I added these two, okay, if I added I1 plus I2, we get dxy plus uh, xy plus dyx plus r1 plus r2. Okay, and now here we see that the dxy and dyx. Okay, so these now replace. So that is I1 plus I2, that is equal to, this angle is a delta from here, that from this delta plus R1 plus R2. Okay, now you see that AXEY is a quadrilateral. AXEY is a quadrilateral. Now that is also equal to, okay, so we know that all angles, sum of all angle of quadrilateral, that is also equal to sum of all angle of quadrilateral AXEY, that is equal to 360 degree. So sum of all angle means angle A plus angle E. Sorry, no, actually angle E we try to replace. Okay, angle A plus angle X. So that normal means 90 degree. So that means angle X here from 90 degrees, okay, plus angle E. What is the value of angle E? So if I check the triangle EXY triangle, here angle E plus angle R1 plus angle R2, you know that sum of all angle of a triangle, that is equal to 180 degree. Now we replace that, okay. So angle E equal to 180 degree minus R1 plus R2 in bracket. Okay. Now next angle. Next is called that's also. They are also, if we check, that is also perpendicular. This yellow color line on AC, yellow color line on AC also perpendicular. So that is also 90 degree. Okay, plus 90 get 360. Okay. So angle A plus 90, 180 and 90, that's also added at 360 degree. Cancel. So plus minus minus R1 plus R2 equal to 0. So angle A equal to R1 plus R2. Okay. So now replace R1 plus R2 here. Here replace, we get I1 plus I2 equal to delta plus angle A. Now finally get delta equal to I1 plus I2 minus A. Okay. So deviated angle. Okay. Finally find the delta, deviated angle. Okay. That is depending on I1 and I2. I1, if I said the I1 is incident angle and I2 is the emergent angle, and that angle, okay, the A is the angle of prism. Okay, actually the A is that the angle of prism. Okay. Okay. So that's angle A is called, this angle A is called angle of prism. Okay. Now next part. So now we derive the delta, and now the factor affecting that angle of deviation. Okay, is it a factor affecting the angle of deviation? Okay, see that equation. Okay, very easy. So if the factor is an angle I, the incident angle first. Okay, so first the incident angle. So first is the incidence angle. Okay, so depending on incident angle means I1. Next, that's the refraction bending. Okay, that's the bending of refracted ray, that depending on the refractive index. Okay, so that's the material of prism. Again is the material of prism. Material of prism means the Ri of medium or material actually. Okay, next third factor depending on angle A, because that means if angle A, that is defined because the slanting, actually the angle these two, if angle A is more, so angle B is less and C also less. If A is more, BC is less. So now the normal changes. Okay, if it's more slanting actually, so if there is a more less than, almost A is less, So these normal line almost at near to tending to parallel to BC, parallel to ground. Okay. Similarly, that the AC surface also, if AC is A is less, so AC angle is more, so tends towards 90-degree angle C. So that's these normal tend to parallel to align to BC or parallel to BC or surface actually. Clear? Angle also important. Now the number 4 important factor is called a color or wavelength of light. Color or wavelength of light. Very important. Okay. This 4 factor is affecting the angle of deviation. Okay. Now next topic. Determine the angle of deviation and angle of incidence. So now we try to draw a graph. Okay. So draw a graph delta versus I incidence angle. Okay. So if here, okay, that is a delta and here that I. So actually the graph now will look like this. The graph is look like this. Okay. So we check that point. Okay, now analyze the graph. That is the lowest point. Okay, means delta minimum. That point is called delta minimum. Okay, if incident angle, some value of incident angle here. Now, if now delta tends to max. Okay, so if when delta tends to max, suppose choose here any value of delta, not max, actually any value of delta. So here we get, here is I1, that is I2. Okay. So check that a minimum delta when is possible, when just only one I. So delta mean, actually delta mean we get I1 equal to I2. So I1 plus I2 minus A, here I1 I2 I'll say that I, that is 2I minus A, the delta minimum. So these here I1 equal to I2, that is a minimum deviation here. Okay, that is a minimum deviation. You see diagram is I1 equal to I2, so that is the I plus I, that is 2I minus A. That is a minimum deviation here. But A more than minimum, suppose that here we get a 2 value. Okay, incident. If is here also I1 dash, suppose I2 dash. Okay, so here all possible two value, but here only we get a one value of incidence. So that's mean here I1 or I2, that's to I1 or I2 are equal. Okay, clear? Now, so that means that the incident ray at which the incident suffer the minimum deviation. Okay, that's called position of minimum deviation. So the position of minimum deviation, the refracted ray inside the prism is parallel to the base. Actually, you see the diagram, that is a refracted ray. Let's say that is a refracted ray parallel to base. Actually, minimum deviation here. Now, if I draw a clean diagram, that's not a triangle. Okay, that is incident angle. If there is a parallel to base, okay, that is refracted angle parallel to base. That is normal here, that is a normal here, that is I1, that is I2. Here to check that, that is if that is a parallel to, that is refracted base, so I1 equal to I1 equal to I2. When I1 equal to I2, we get delta minimum. So here when delta minimum means refracted ray, means these rays are parallel to base of prism. Okay, clear. And these triangle, okay, and another important factor, these A, B, C, the triangle, there is an isosceles triangle actually. Okay, so these angle B and equal to angle C. Clear? That is a minimum deviation. So I draw the triangle thinking that is the minimum deviation actually. Okay. Now some consider some, take an example here. Clearly concept from example. Suppose that if I draw a triangle here, suppose triangle here, that is an isosceles angle also. Okay, actually, so that is incident angle is 70 degree actually. Okay, 70 degree, and suppose the follow the straight path. Okay, so now this refracted ray is not parallel to the base, so after the striking they now parallel to base. So actually here that suppose there is a normal here. So these angles, some let's just say that that is 33 degrees. Just say 33 degree, and A is given. Suppose consider that A here. So 48 degree. Say that A is 48 degrees. Now calculate delta. So delta equal to 70 plus 33 minus 48. So I get that is 103 minus 48, 52 plus 3, 55 degree. So deviation is, now the deviation is the back from this angle is 55 degree. Okay, that is just only examples. Okay, let's see. Say, and say if they are same, suppose consider the another example. Suppose take this here, this triangle. It is incident ray. Now refracted parallel to the base of triangle. Now this, suppose consider these two angle is, suppose say that the 48 degree, and here also say the 48 degree. Okay, now that angle is consider, suppose same, uh, say that that is 60 degree. Okay, so what is the value of delta? Say that delta is I1 plus I2 means 2I2, 48 plus 48, 48 plus 48 minus 60 degree. So in that case it's 96 minus 60, or say that if that is the same triangle here, that is 48, because that is a 48, that is also, that is 48. Okay, so that is a 40. Say that 48. So 48. So 48 minus 96, that we get a 48 also. So here the minimum delta minimum, that is minimum deviation here. Okay, that is a minimum deviation. Okay, clear. If a same triangle of prism ABC here, these are same triangle A, B, C. Okay. So that's important concept here we learn that if a refracted ray parallel to base, that is a refracted ray parallel to base, we get a minimum deviation. That's the important keep on understand. Okay. Next topic we discuss the dependence of angle of deviation on refractive index. Okay. Here you first discuss that angle of incidence. Okay. So discussion the factor of incident angle. How delta depend on incident angle. Now discussion the how delta depend on Ri. Actually very important depending on Ri. Uh, uh, Delta depending on mu Ri refractive index. Okay. So higher refractive index produce greater deviation. So higher Ri produce greater deviation. So higher Ri produce greater deviation. Get it. Okay. So smear lower Ri produce lower deviation. Okay. Suppose there's an example mu of faint glass, flint. Mu of flint glass, okay, is much greater than mu of crown glass. Okay. So clear concept. The faint glass is produce a more refractive angle uh, than crown. Okay. So mu of these two, if mu of is more, so if higher mu produce higher deviation, so similarly the delta uh, flint glass greater than delta crown. Yeah. But both are same angle A. If though are both if both glass have same angle of prism, but that is a mu delta is different because their Ri or material is different actually. There is a material is different. Mhm. Also say that the two glass and suppose another or here, okay, both are the reflective. Actually here is not a made actually not make a prism. Okay, so clear. Next, the next concept is that factor is angle A, angle of prism. Okay, third point, angle A, that is also depending on angle A. Third point, depending on angle depending on angle A, delta depending on angle A. Delta increases, so increase in angle of prism. If A increases, so delta increases. So delta directly proportional to angle A. Okay, angle increases, so delta also increases. And there's a direct. And number 4 and last factor is depending on color, delta depending of light. So if I draw a Vibgyor rainbow V to R, so you know that velocity of violet is less than velocity of red. Okay, more than velocity of red. Sorry, less than velocity of red. So you know that mu refractive index of violet actually that's V. It's not represent a capital V. Okay, usually small v represent velocity. Okay. that is V is also greater than mu of R. Okay. So if now say that if we say here check that is mu in more is means delta more. So delta of violet is more than delta of red. Okay. So you see that is mu more means deviation more actually. Okay. So decrease and increase in the wavelength. So actually, so we know that red has a more wavelength, right? So decrease increasing wavelength. Okay. So here we know that the red has a more wavelength. So red lambda of R, and here V equal to we know that f lambda, frequency of lambda. Okay. So here velocity more is lambda more. Actually frequency is same. If velocity is more is lambda more. Velocity and lambda they are directly proportional. So violet uh, lambda and red lambda. Violet of lambda is less than lambda of R. So actually see that from previously we see that is violet as more deviate than red finally actually. Okay, so more deviate than red. Clear? Okay, so next class we discuss another topic of simple application of refraction of light. So today I end the class here. Thank you.